Longest name.
No, I'm going to do search party first. So first I'm going to do search party. So we'll do const search party is equal to a function that takes in, what does it take in? It takes in the name of the person you're looking for, and it takes in a world object. So search name basically says, I have to return to you an array of directions to find the person I'm looking for. So it's a little complicated just thinking about it, but honestly, the world variable represents an object, and its values are just places. And basically, if the value of that place can be three things. It can be another place represented by an object, an array, which means there's more than one person there, or a string, which is one person is there. So we have to find our one person and return directions on how to get there. So right away, this is a pain in the ass. So let's do this, right? So we know that the world is an object, and we know we have to loop through it. So we'll say let's place in world, okay? Because we're going to be doing a lot of loopings. I know that right away because there's multiple nested different kinds of complex values. So I'm just going to make this easy and say this is going to be a place in this world, okay? So the first thing I can do is if type of world of place is going to be equal to a string. That means that there's one person here. I don't have to do anything else, okay? All I have to do is I have to check if that person is the thing we're looking for, right? So if world at place, because world of place is a single person, right? So if world at place is equal to name, what do? We have to return an array of directions to get there. Well, if we just found the person, then we just return an array with place. Because place is the actual place where that person is at. The value, world at place, would be the person. However, the key, place, would be the place. Okay? Is everyone with me so far?
Can I ask a question?
Yeah.
So when that place, is that place going to be like 11th floor? Or is that place going to be world full stack 11th floor?
The place would be either full stack. It could, like, you see the, are you looking at the,
Yeah, I'm looking at the data.
So if you look at problems, you look at search party, right? You look at the readme. It's slow when I'm recording. Well, yeah, we'll look down here, right? So it can be full stack. It can be 11th floor, 25th floor, or it can be subway. Right?
But it's only going to be one of those when you do place, right?
Yeah, place is always going to be a key. So the keys will always be places.
Right, but I'm saying it won't, because I thought when I read this that you'd have to return that you're at full stack on the 25th floor.
Yeah, we will.
Okay.
We're not up to there yet, right?
Okay.
So this is just saying that, like, if the key's value was a string, if the key's value is a string, that means that we are at a person.
Key's value is a string.
If the key's value
is a string, yes.
is an object, that means there's other places. If the key's value is an array, that means there's multiple people, but no more places. So if we are down here and we get that string, we're just going to return in this part an array with just 11th floor. Okay? That's where we are now. We're not building up anything yet. We're not incorporating this yet. We haven't, because this would happen if the value was an object, right? So let me go back to here. So that happens if we hit a string. We just return place. This is our base case. When we hit the string, this is our base case. We're just returning a single array with that place. But there's another base case, right? There's another base case, and that's else if array.isArray, right? Array.isArray of world of place, right? If that thing is an array, that means that there's multiple people here. However, that also means that there's no more places. So if there's no more places, we don't have to recurse down anymore. We have a list of people here. And the reason we have to do this before the object is because type of array is object. So you always have to first check the more specific thing. The more specific thing is array.isArray, right? So here we have...
It's the A in array.
Oh yeah, my bad, thanks. So here, if array.isArray, right, we say if world at place dot includes name. If the person's name we're looking for is included in that array. If that is true, we can also return the same thing, right? Bracket place. Because we know that we are at one place. Now, this is the tricky part. Now we know that the value is not a string, and the value is not an array. So we know that it must be an object. So if it's an object, we can say let next place equal world at place, right? So we'll say let next place is going to be world at place because we know that this is an object. So we can say let return value is going to be equal to search party at, we'll pass invoked with next place. So we'll pass that object into search party, okay? And returned value, as soon as we get to a string or an array, we'll return an array of that place. So this is always going to return an array. So what do? We say if, otherwise, if we find somebody, it will return this. Otherwise, we return null. So if returned value is not equal to null, that means that we can return place dot concat with return value. And that's it. So here we know that we have to go recurse down deep into a nested places, right? So that's what we do here. But what does this return? I forgot to say that it returns null if you can't find anything, right? If you can't find this person, you return null. So this is either going to return null or it's going to return an array of the inner places, right? So the array of the, whatever it is, it gets spit back up. Then we say if this is not equal to null, or we can just say if it's truthy, right? If returned place. Then we can return the current place that we're at concatenated with whatever place it's spit back up. And this will be spit back up and concatenate until we go back to the original place. So here in search party, if we're looking for Francis, we hit Francis, so we return an array, we return an array of 25th floor, right? So the array of 25th floor, we were up to here before, right? And we had to dive deep down into here. So the answer would return an array of full stack dot concat with what this returned, which was an array of 25th floor. So it would be full stack, comma, 25th floor. Tricky, right? You got to take into account every single type. What are you shaking your head? What, it's not hard for you?
I told you recursion to me is just I don't know why,
Oh my
but like
gosh.
it makes so much more sense to me than stupid like while loops. While loops can whatever. Like but recursion, like I don't know, it just clicks with me. We're like friends.
Recursion's like, I don't know. I feel like one day for all of you, I feel like recursion will click. It is gonna click. It's gonna be like, oh, okay, and then you kind of stop doing the call stack thing in your head, and then you kind of you can kind of see what's gonna happen. You know what I mean? So, oh yeah, any questions on this? Cool. So now I will do const, what is it, get longest name. And this is going to take a family, right? A family. So this, in my opinion, is tricky because the things we're looking at the whole time are keys. Because the keys have the family names, right? So, but right away we know we have let longest name, no, let longest name equal to an empty string, right? So the first thing we know is that this is an object, right? So we do for let name in family, right? We say let name in family. So we're going to loop through this family. Right away, we know that since we're looping through this object, we know we have a key value pair, right? So that means we have the key, and the key is the family name. So right away, we can say if name is dot length is greater than longest name dot length. If this is true, then longest name is now equal to name. We reassign longest name to be the current name because the current name is longer. Now that we got that out of the way, we can have two things as values. We can have an object or we can have null. Okay? So we have to check if this has an object as a value because the object represents descendants, right? So we can basically say if family at name. We don't have to do type of because if you remember, type of object and type of null are both object, okay? Type of null being object is an error in the language, but it exists and you have to work around that. However, we know that an object is a truthy value and null is a falsy value. So we can just say if family of name, okay? So if family of name, we'll say let inner longest name equal the return value of get longest name invoked with family at name. So we go down the family line, right? Then inside of here, like with all systems go, how you had to kind of do something if we went recursively down, if we found a false, then you had to treat it right below it. Okay, if this is false, return false. We have to do the same thing here. If inner longest name dot length is greater than longest name dot length, we can basically say longest name is now going to be equal to inner longest name. Right? Then at the very end, we return longest name. So maybe this will help if I look at this example in the README. So in the README, right? So like each time the first thing we do is we check to see if this is the longest name, right? So in the README, we check to see if this is the longest name. Then we check to see what the value is. If the value is null, we don't do anything. If the value is an object, then we call longest name again on this object. We check to see if this is longer than the longest name. Okay? So far, in this recursive call, it is, because in this recursive call, longest name gets set to an empty string. But then this value is still here, right? So then we go and we loop through this object. And when we loop through this object, longest name is an empty string. So we check this is longer than an empty string. Its value is null, no recursion. Is this longer than William Rhodes? No, so we don't set it, and we don't do recursion. Is this longer than William Rhodes? It is. So we reset it, but its value is null, so we don't do recursion. So the answer to get longest name when we pass in this object is Sir Paddington IV of the county Wilstonshire, right? So this gets returned up to here. This string is longer. Then we have to compare what the return value of the recursive call is to what our current longest name is. We do, and we reset it. Then we return that to here. We compare again. We reset it, and then since we're done, we return Sir Paddington IV, the county of Wiltshire. Any questions on get longest name? Not too bad, right? All right.